My dear students, welcome to DM Pannade classes YouTube channel. Now we will discuss class 12 maths exercise 1.1. Question 1, determine whether each of the following relations are reflexive, symmetric and transitive. First one, relation R in a set A is equal to flower bracket 1, 2, 3, 4, 5 dash 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 13, 14 defined as R is equal to flower bracket R is equal to flower bracket ordered pair x y such that 3x minus y is equal to 0. Okay, here my dear students, the relations are defined like this: R is equal to flower bracket x y such that 3x minus y is equal to 0, and the set is A is equal to 1, 2, 3 dash 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 13, 14. Solution. My dear students, we know that the definition for reflexive A1 A1 belongs to capital R for all A1 belongs to given set A. This definition for reflexive. Okay. A is defined. A is given. A is equal to 1, 2, 3 dash 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 13, 14. The relations is defined like this: R is equal to R is equal to ordered pair x y such that 3x minus y is equal to 0. Okay, here 3x minus y is equal to 0. Okay, here this can be written as in the form of y is equal to 3x, y is equal to 3x. Okay. Put x is equal to 1, put x is equal to 1 from this set, and y is equal to what? Put x is equal to 1, y is equal to 3. Okay. And similarly x is equal to 2, put this is equal to 2, x is equal to 2, then 3 into 2 6, x is equal to 2, y is equal to 6, again x is equal to 3, y is equal to 9, 4 is equal to x is equal to 4 and y is equal to 12. Okay, here we can't consider x is equal to 5, x is equal to 5, we can't consider x is equal to 5. Okay, here suppose we consider x is equal to 5 in this equation, x is equal to 5, then y is equal to what? Y is equal to 3 into 5, 15. Okay, here x belongs to given set A, but not y is equal to 15 does not lie in set A. Because of this, we can't consider x is equal to 5. Okay. Therefore, by using the given set A and the relation R, and by that okay, here then after that we write the relation R, or the relation R is defined like this: x is equal to 1, y is equal to 3, 2, 6, 3, 9, 4, 12. Okay. Okay, here by we observe that this relation R is not reflexive, because we know that the definition for reflexive A1 comma A1 belongs to R. But here 1 1, 2 2, 3 3, 4 4, 5 5 dash 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 14 14 does not belongs to R. It means these ordered pairs does not lie in capital R. Because of this, R is not reflexive. Okay. Next, R is not symmetric. R is not symmetric because 1 3 belongs to R. 1 3 belongs to R. Okay. 1 3 belongs to R, but 3 1 does not belongs to R. Okay. Because of this, R is not symmetric. R is not symmetric, because we know that the definition for symmetric A1 A2 belongs to R implies that A2 comma A1 belongs to R. A2 A1 belongs to R. Therefore, R is reflexive. But here in this example 1 3 belongs to R, 3 1 does not belongs to R. 2 6, or we consider another pair. 2 6 belongs to R, but 6 2 does not belongs to R. 3 again we consider another pair. 3 9 belongs to R, but 9 3 does not belongs to R. 4 12 belongs to R, but 12 4 does not belongs to R. Because of this, R is not symmetric. Okay. Next, R is not transitive. Okay, R is not transitive, as 1 3 belongs to R, 3 9 belongs to R, but 1 and 9 does not belongs to R. Okay, because of this, R is not transitive. Hence, R is neither reflexive nor symmetric nor transitive. It means R is not reflexive, R is not symmetric, R is not transitive. Okay, this is the first example solution. Okay, next, second one. R is equal to flower bracket ordered pair x y such that y is equal to x plus 5, and one more condition is given, that is x is less than 4. Okay, x is less than 4. Okay, here the set is natural number. See example number 2. Okay, here the relation R set n of natural number defined as R is equal to y is equal to x plus 5 and x is less than 4. Okay. Next, solution of this question. Okay, set is natural number. Set is natural number. Okay, set is natural number. Set is natural number. Okay. Next. Okay, here we consider x is equal to, the possible values of x are only 1, 2, 3, because these numbers are natural number, and less than 4. Okay, we can't consider x is equal to 0. We can't consider x is equal to 0. We can't consider x is equal to 0 because 0 is not natural number, but 0 is less than 4. Okay. Next. Okay, here by using this given set natural number, and by using these conditions, we define the relation R like this. Okay, x is equal to 1, y is equal to 1 plus 5, 1 plus 5 is 6. Again x is equal to 2, y is equal to 5, y is equal to 2 plus 5 is 7, and x is equal to 3, y is equal to 8. This is our R. Okay. Then by using this R to check R is reflexive or symmetric or transitive. Okay. In this R, 1 1 does not belongs to R, or 2 2 does not belongs to R, 3 3 does not belongs to R. Because of this, R is not reflexive. Okay. Next, to check symmetric, 1 6 belongs to R, but 6 comma 1 does not belongs to R. Because of this, R is not symmetric. Okay, R is not symmetric. R is not symmetric. Okay, this small correction is there. This is not 1 6. This is 6 1. 6 comma 1 does not belongs to R. Okay. Therefore, R is not symmetric. R is not symmetric. Now check R is transitive or not. Okay. Since there is no pair in R such that xy belongs to R and yz belongs to R, then xz cannot belongs to R. Because of this, R is not transitive. Okay, R is not transitive. Hence R is what? R is neither reflexive nor symmetric nor transitive. It means R is not reflexive, R is not symmetric, R is not transitive. Okay. Next example, example number 3 in sub question 3. The set is given A is equal to flower bucket 1, 2, 3, 4, 5, 6, and the R is defined like this. R is like this, ordered per x, y. Y is divisible by x. Y is divisible by x. It means y by x. Okay, y by x. Okay. Next, we know that this result. Okay. Any number x is divisible by itself. Okay. Because of this, xx belongs to R. Xx belongs to R. Okay. Xx belongs to R. Therefore, R is reflexive. Okay. Next. Now check symmetric. 2, 4 belongs to R. Because 4 is divisible by 2. Okay, 2 1s are 2 2s are. Okay. Because of this, 2 4 belongs to R, as 4 is divisible by 2. Okay. Next, but 4 2 does not belongs to R, as 2 is not divisible by 4. Okay. 4 is divisible by 2, but 2 is not divisible by 4. Because of this, R is not symmetric. Okay. R is not symmetric. Next, check transitivity. Okay. xy belongs to R, yz belongs to R, then y is divisible by x, and z is divisible by y. Therefore, z is divisible by x. Z is divisible by x, it means xz belongs to R. Therefore, R is transitive. Okay. Therefore, we conclude that R is reflexive, transitive, but not symmetric. Okay. Next sub question number 4. Okay, here this question is very important for your annual examination purpose. Okay, R is equal to flower bracket ordered by x y such that x minus y is an integer. Okay. Okay, the set is z. Okay. Now check reflexive. For every x belongs to z, xx belongs to R. We consider x is equal to any integer. Then substitute the values of x in this condition. X minus x is equal to 0. 0 is an integer. 0 is an integer. Okay. Therefore, because of this, R is what? R is reflexive. R is, which is true. Okay. Next. Now, for every xy belongs to z, it means xy belongs to R. Then x minus y is an integer. Then take out common factor minus, or take outside minus. Then x minus y is also an integer. Therefore, implies that y minus x is an integer. Therefore, yx belongs to R. Therefore, R is what? R is a symmetry. Because we consider x is equal to and y is equal to some particular values. Then we consider x is equal to 1 and y is equal to 2. This is equal to minus 1, and minus 1 is an integer. Okay, belongs to z. Okay, or 2 minus 1 is equal to what? Again 1, and this is also belongs to z. Okay, because of this, R is reflexive. Next, now xy belongs to R because x minus y is an integer, and yz belongs to R because y minus z is also integer. Okay, for all x, y, z belongs to z. X minus y integer, y minus z is also integer. Then x minus z is equal to x minus y and y minus z. Minus x minus y plus y again get cancelled, we get what? Again x minus z. Because of this we must be adjusted by using minus y and plus y. Okay. Next, and xz belongs to R, therefore R is transitive. R is transitive, hence we conclude that R is reflexive, R is symmetric, R is transitive. Okay. Next example. Okay, here example number 2. Okay. Next we consider next example. Okay. Question number 2. Okay, questions is like this: show that the relation R in the set R of real numbers defined as R is equal to what? R is equal to flower bracket AB. A is less than or equal to B square is neither reflexive nor symmetric nor transitive. It means to show that R is not reflexive, R is not symmetric, R is not transitive. Okay. R is like this, ordered pair AB such that A is less than or equal to B square. Okay. Okay, it can be observed that 1 by 2 does not belongs to R because of this reason. Okay. 1 by 2 is greater than 1 by 2 square. 1 by 2 square is equal to what? 1 by 2 square is equal to 1 by 4. Okay, here 1 by 2 is equal to 0.5. 0.5 is greater than, I think, 0.25. Okay, 1 by 4 is 0.25. Therefore, because of this, R is not reflexive. Okay. Next we consider, next check symmetric. 1 4 belongs to R. 1 4 belongs to R. Okay, here the condition is like this: A is less than or equal to B square. Okay, put A is equal to 1 and A is equal to 1, B is equal to 4, and 1 is less than 4 square. 4 square is 16. Definitely 1 4 belongs to R because this ordered pair satisfying this condition. Okay, but 4 is not less than 1 square. Because of this, 4 1 does not belongs to R. 4 1 does not belongs to R. Therefore, R is not symmetric. Now check transitivity. Okay. Now 3 2 belongs to R because 3 is less than 2 square. 2 square is equal to what? 4. 3 is less than 4, which is true. Okay, belongs to R. And similarly, 2 comma 1.5 belongs to R. But 3 is greater than 1.5 square. This is 2.25, which is not true. Okay, which is not true. Because of this, because of this, 3 comma 1.5 does not belongs to R. Therefore, R is not a transitive. Okay, R is not a transitive. Then we can conclude that R is neither reflexive, symmetric nor transitive. It means R is not reflexive, R is not symmetric, R is not transitive. Okay. Okay, here now we stop this session, continue in the next class. Okay.